on the TI-84 Plus, so you need to have your graphing calculators with you. So this is a quick review of how to use a TI-84 Plus graphing calculator to do the following. So what do you think the first thing is?
Graph a function.
Yeah, graph a function, yep. It's easy. So graph a function. Adjust the window. Window is like a button. Fix the required D and R. Yeah, that's right, domain and range. So you'll probably notice that in a lot of questions they specify what domain and range. So you've got to make sure your graph doesn't go outside of that specified domain or range. Find any X things. Intercepts, yeah. How do you find the X intercepts? You do a thing like second calc. The X intercepts, they don't call it on the TI-84, they don't call them X intercepts, they call them something starting with Z. Zeros.
Oh, were you asking us specifically?
Yeah, so find any X intercepts, they call them zeros. So of course to graph the function, you go to the Y equals button. To adjust the window, you go to the window button.
What do you mean by zeros?
X intercepts.
Count.
Yeah. So once you've graphed,
it just says zeros. You press it and it gets your answer.
Yeah.
Second count.
Second calc and then zeros is how you find the X intercepts. And then it asks for the left bound and the right bound, that kind of thing. Did you want me to scroll up? No? Okay. So it asks for the left bound and the right bound. Find any Y intercepts. Find any Y intercepts is what we're asking there. To do them, you would have to go second calc and value. And at the Y-intercept, what is the X value? Always a 0. 0, yep. So then you have to type in 0. Yes. So, yeah, that's right. That's how you could find the Y-intercept. So you go second calc value, because at the Y-intercept, X equals 0. So let's maybe we can do that. At Y-intercept, X equals 0. That's why. Find any maximums or minimum.
Which ones cancel?
Same thing. You would go second calc. Second calc, and if you go second calc, you can either select maximum or minimum. Select max or minimum. So again, thanks, back to you. Yep, so second calc, select max or min, and again it asks you to select the left bound and the right bound, it's that kind of thing. So be good at doing that. Find any vertical asymptotes. Yeah, asymptotes. Shall we spell it? Asymptotes. Find any vertical asymptotes. Yeah, that's right, yeah, thank you. Yeah, horizontal asymptotes. To find any vertical asymptotes, you can trace the graph, or algebraically, you can set the denominator, if it's a rational or a reciprocal function, set the denominator equal to 0, and solve for x. So that's how you do it algebraically. You set the denominator equal to 0 and solve for x. That's if it's a rational or a reciprocal function. If it's a logarithmic function, then it's going to have a vertical asymptote. If it's an exponential function, it'll just have a horizontal one. To do it with the button, you can go trace. The trace kind of helps you to some extent find it. Some people also said, or table. You press second table to open up table?
Yeah.
The second table.
Oh, yeah.
Yeah. Or second table. And then I think the one that's undefined. Oh no, they call it error, don't they? And then look for error. And look for error. So tracing kind of just helps you to see, is it getting closer and closer to the asymptote and not crossing it? That's one way you can check. For sure. Or you can go second table and look for the X value that's got error associated with it. Katie, are you also taking anything? Oh, you're just waiting, You're multitasking? Just make sure you put this, which you probably do. Okay, so that keeps popping up. and you vaguely try to have a guess at the horizontal asymptotes kind of thing. We've got our, oh yeah, because with the calculator, it's only a vague one. At least with the calculator, you could get the exact vertical ones using that second table.
Or you can,
But unfortunately, all you can really do to check the horizontal one is to trace. There's no table kind of thing that you can do to find out exactly where the horizontal asymptote is. I don't think so anyway. I've never noticed it pop up. But tracing, you can kind of like have a vague guess because you'll notice it'll get closer and closer to what you think is the asymptote. So you can also do it algebraically. To find a particular y value, like you know how sometimes in your topic assignments, when you were kind of doing a graph, sometimes there was one graph, was it something like this? And people's heights at the end at 2.25 weren't quite right. So the way to find out its height is, if you're doing it on the calculator that is, you go second calc and value and just put in whatever the x is. So in this case it would be 2.25. And then it'll tell you what the y value, what the height is, what the y value is for that. So similar to how you found the y-intercept. Second calc value and put in 0, because x is 0 at the y-intercept. But if you want to find the height at any other value of x, like you know the y-coordinate, but for any other x value, you can do it the same way. Second calc value and type in whatever the x is, and it'll give you its height, its y value. So that's helpful for little extreme points, like something here, like what is the exact height of that point, what's the exact height of the other extreme point, so that when you're graphing you can't lose marks for it. Because in the mark schemes, they'll draw a little tiny circle around those endpoints and say it's got to be within that circle. And if your height's outside of that circle, then you don't get you lose a point. So that's how you get the extreme values using the calculator. You can also sub in x into an equation if you've got the equation. But this is how it's done on the calculator, because that's what this topic is, calculator. Another big thing is graphing two functions together on the same set of axes and finding the something to solve for x. Intersected. That's it, finding the intersection. Yeah, finding the intersection as a way of solving for x. So to find the intersect, you go second, calc, and then you want to guess what you would select. Intersect. Intersect. And then you press enter 3 times. Like, because it says first curve, so you press enter. Second curve, it'll automatically go into it, enter, and then guess. Yep, so after it says guess, you have to press enter one more time. So enter, 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 enter. Intersections are the only ones that seem to have this. The other things tend to be you either enter in the x value, like second calc value, or you do the left bound, right bound kind of thing. Second calc intersect, and it'll give you the x and the y. But if you're solving for x, then you would only say what the x is. So that's a way that you can. Because
you have to do left bound, right bound, and
yeah, and then it says guess question mark, and then you have to press enter one more time. Oh, actually, in this case, it's enter because it says first curve, so you just press enter, and then it'll automatically jump onto the other curve. So it tends to do that for you, and then you just confirm it and say enter, and then the third one. I guess if you had 3 things graphed at once, that's why they kind of just want to check if you got the right 2 curves. But most of the time, you'd only graph 2 things together.
The Miss Mary can
Sure thing. So here?
find where's the max and minimum?
What is that? Up here? Oh, yeah.
Okay.
Finding the maximum, minimum, second calc, maximum. Then do the left bound, right bound for that one. So here's a pretty crazy graph. So this one's got a few features to it. It would have a x-intercept. It would have an x-intercept here. Does it have any y-intercepts? Yeah, it's got a y-intercept. Does it have any maximums or mins? So this could potentially be a maximum. You would have to double check by finding it on the calculator. Second calc, left bound, right bound. And if it doesn't find a maximum, then you know it's not a max. This could be a maximum for sure. That looks like a maximum. But this one is a bit vague. It could just be drawn a bit weird. Yeah. Now we actually get to practice doing stuff like that. Here's an awkward axis. Might need to zoom out a bit so we can see it a bit better. What are we on? There you go. Here's an axis. So you guys are pretty good at, I've noticed, at doing your axes, but like say, how would you like, yeah. What am I trying to say? So it's kind of like 5 is difficult to set up the axes for because it's an odd number, but when it's an even number, would you agree you can go halfway down? Is easy enough to do, and mark in 4, and then halfway from there would be 6, and then halfway from there would be 2, and then you can do all the ones in between. But then just double check, is your axis even? Year 11s at the moment aren't great at doing this, so I'm trying to train them into doing that. Their axes are, if it's a little bit off, like, you know, a tiny bit off, it's fine, but if it's really, really obviously off, then that's a problem. So I'm marking that one as being 4. And then we've kind of got to do the same with this one. So 1 to here is kind of like about 1, 2, 3, 4. Sorry, it's a bit hard to do. So 1, 2, 3, 4, 5. -1, -2. So you just try to do it as best as you can, so that if I looked at it visually, I couldn't see that. It doesn't look to me like the scale's uneven anywhere. So if it is uneven, like say for example to me this looks too big, and that look compared with that one, so I would redo this if I could be bothered. If it was an assessment, I would redo this scale because this part here is quite big compared with that part there. The vertical one's not too bad. So yeah, try to be fussy with your scale. You can mark in 1, 2, 3, 4, 5. In fact, let's do that.
Yeah, I would, yeah.
1, 2, 3, 4, 5, 6, 7. -1, -2. Here's our awesome scale. And what kind of function is this thing? Good guess? Good guess? It's a crazy one. Yep, it's a crazy one. And it starts with R, this type of function. It's a reciprocal function. It's got a bit of vertical shift in it. What would be the vertical shift? 3 units, yep, just out of interest. What type of equation is in its denominator? Quadratic. So how many asymptotes do you think it might have? 2, yeah. Good. Just pointing out why, because if you probably can't see it very well. There you go. If you factorize this little baby and solve, if you set it equal to 0 and solve for the denominator, you'll get 2x values. So we're going to do this on the calculator, but I just love doing this. So let's do x squared minus 4x plus 3 equals 0. So this is for the asymptotes. What does that factorize to? Because this is part of our topic on quadratics. Close? Two numbers have to multiply to give 3 and to give -4.
No, 4 subtract 1. 4 subtract 1.
They have to multiply to give positive 3 and add to give -4.
I thought it was -1, -4.
Really close?
-3 and -1.
-2 and
-3 and -1, yeah. Because they have to multiply to give positive 3 and add to give -4.
Also the opposite.
Me too.
Yep, -3, -1. So we're... Yeah, sure. So where are our
I'm going to go down to sugar.
So where will our 2 asymptotes be?
X 3, x equals 1.
Yeah, x equals 3, x equals 1, yeah. That's it. So that's how you find the asymptotes. You could confirm, I would confirm it by doing it on the calculator too. So I'm going to mark in those lovely little asymptotes and mark them in yellow. X equals 3, x equals 1. I might need to zoom out a bit now. What was I on? Zoom. Go away. Okay, zoom. To there, maybe. That's a bit better. Yeah. So here's our. So I don't like it when people don't put in the equation of the asymptote. I get a bit cranky about that. So make sure to mark in your equation of the asymptote x equals 1. And then this one will be 3. And hopefully when we sketch it on the calculator, this will confirm, like you'll see from the general shape, that there should be asymptotes there and there. Oh, you've sketched it, cool. Yeah, so what does it ask? On the diagram, sketch the graph of blah blah between, check things like this, -1 and 5. And that's good, it does match the axis. But if it didn't, sometimes they'll trick you. They'll say sketch it from -1 to 3, and they'll have drawn the axis up to 5. So be careful of them tricking you with stuff like that in the question. But here it does say sketch it from -1 to 5, so we can use the whole axis. Then write down the equation of the 3 asymptotes. So there is actually going to be reciprocal functions tend to have horizontal asymptotes as well. And where is the asymptote generally for a horizontal? For a reciprocal function, where would the horizontal asymptote? Close? If it was just this part, it is going to be at 3 because it's been shifted up. So if it was just 1 over this business, it would be through y equals 0. But Paige noticed that it's got +3, so she's realised that the asymptote's gone from being the regular one for the reciprocal through 0, it's gone up to 3. So we can draw that in too. So it's going to have a horizontal asymptote. Okay, so y equals 0. Make sure your asymptote kind of just stops. That's -1. Y equals 0 is our horizontal asymptote. And make sure kind of your graph doesn't go outside of -5. So we've got our asymptotes horizontal one because it normally for a reciprocal it would be through y equals 0. But because of the +3, it's been shifted up 3 units. So I still haven't answered A, by the way. But I really want to do this one. So you see I'm just avoiding sketching it. So we've got x equals 1. X equals 1. X equals 3.
Wait, so did you just figure out the horizontal asymptote?
Yeah, by looking at the fact it's a reciprocal function. So 1 over that business means it's normally would be through reciprocal functions are normally through y equals 0. But because of the +3, it got shifted up 3 units.
Wait, why is it a reciprocal function?
Because it's 1 over a polynomial. Like a constant, reciprocal functions are like k over some kind of polynomial, like x plus 1 or something like that. So k is just a constant like 3 or 1, 5. So it's a reciprocal function if it's a constant over a polynomial, like it could be a linear equation or a quadratic or a cubic on the denominator. If it's got x over a polynomial, like a polynomial over a polynomial, it's instead called a rational function. Reciprocal is a special one than constants on the numerator. Okay, so I really can't avoid this anymore. I have to just do the graph. So at this point, we're kind of forced a little bit. We probably should be doing it on the calculator now. Where is it? Where's my calculator? Here it is. So again, of course, we go y equals 3 plus. Make a nice fraction. Go alpha y equals numerator denominator. Put in your gorgeous reciprocal function. X squared. And then look to see, have you typed it in correctly? Have I made any errors? Can you see the board at all? Have I made any errors?
No, I can't see.
I know it's hard to see. I did. I put in a boo-boo. I put in plus
4x, it's -4x.
Good, yeah, exactly. I'll put in plus 4x.
Okay, but I probably still can't see what you can see.
I can't see.
You're also way over
Yeah,
there.
so check stuff like that. Because sometimes you'll have pressed X, but it just didn't come up. So you just, like the buttons maybe aren't that sensitive. So be careful, like you could have put in x squared minus 4 plus 3 by mistake. So double check all that stuff. And I've got the 3 plus. And then when you graph it, it probably won't look very nice because you won't have the window set up. So there's a general picture. And then where do I adjust it so it looks more like this?
Window.
Window, yeah. Go to window. What's my X-min?
-1.
Yeah. My X-max?
5.
Yeah. My Y X scale stays the same. Y-min?
-3.
-3, yeah. 8. Everything else is awesome. Let's see. Yay! Look at that. So what really gets my goat is when people would get this height wrong and when people would get that height wrong. So how can I find out what that height should be? But imagine I want you to be even more accurate. Yeah, to be honest, yeah, it is kind of like above 3. So it's going to be pretty close to 3. But how could I find out the exact value doing second calc?
Trace.
You could trace. Yeah, you could trace.
Or you could put in, no, x equals 0.
Yeah, good. So at this point, what is the x value at this extreme point? -1. Yeah. So I can go second calc value and then say, okay, at x equals -1, what's my y value? So type in -1. See, it told me. Yay. Oh, it gave me a fraction. Great. Or is that a decimal? I can't see. On yours, what is it? Is it 25 divided by 8 or? Must be. Let's see, mode. I could go to table. Yeah, that's actually a good idea. Is there anything here that's got me in fraction? That's weird.
10 over 3.
10 over 3. But I just want to get it as a decimal one here. Maybe something to do with fractions. Where are we? My float's high, so it should be okay. Radian degree. Ah, there you go. So it's gone on to automatic. I'll force it into decimal. See, I'm forcing it into decimal. So graph. And then I'll go back here. Second value, you could go to table, like Paige mentioned. -1. Yay. Okay, so 3.125. So if I wanted to find out that exact height, it's 3.125. So I can plot that little point here, plot that baby. And as Talise mentioned, it's got to be above the asymptote. So we know it's about there. I also need to find is there a y-intercept? Let's see. Where's my calculator gone? Here it is. Y-intercept. How do I find the y-intercept? Apart from tracing. Second calc value. What x value is the y-intercept? 0, yeah. Good. So let's find the exact thing. 3.3 recurring. Worth finding out because by accident you might have put it at 3.5 and you'd lose the mark. So 3.3 recurring. So about 3 1/3. It's got to be clearly below. And from here you could probably guess that it's kind of just going to go asymptotic. So you see it's kind of getting closer to the asymptote. So we could sketch this part now. So let's sketch this little thing here. It's got asymptotic behavior, kind of going towards that. But don't make it curve around. Some of my year 11s are making it curve around when it's meant to be getting closer and closer to the asymptote. So I'm trying to train some of them out of making their asymptotic graph curve around. And then we need to find out something else. What do we need to find out? Oh, this bizzo. We need to find out the y-intercept or the x-intercepts and the maximum point. Okay, so second calc. X-intercepts, where do I go for them? 0, yep. And then this is the awkward thing where you've got to go left bound, right bound, all that kind of stuff. It's going to take forever. Oops, I'm not left. Am I left now? Yes. There we go. And then guess, so you've got to press it once more. So where's my thingy? Can anyone read that? 1.18, would you say?
Yeah.
1.18. Cool, let's go with that. 1.18, where would that be? About here? Just a little bit less than 1.2. Kind of there. Now I've got to do the other one. So what do I press, Sarah? What do I press to find the other asymptote? I mean, the other asymptote, x-intercept. Yeah, it's a to 0, yeah. So 0. And then I've got to go, am I left of it? A moment. Kind of am. I guess so long as I'm left somewhere, but you normally want to go a bit closer. Am I left? Yeah, I am. Yay. Huh?
That's right.
Oh, I'm finding this one.
That's right.
Oh, never mind.
Yeah, that's a very good question. Like, I'm finding this one, so to be left of it, I've got to be over here somewhere, which happens to be above. And now to be right of it, I've got to be down below. It is confusing. And then guess again. And, well, you can always check, like, did it turn up where it's meant to turn up? So see it's where it's meant to be. Yay. And what's that? I can't see it. 2.8. 2.8. 2.8, where would that be? About here. So they're kind of symmetrical, and we kind of need its maximum because I might plot the maximum as being here, and maybe it's meant to be down here. So they are pretty strict with this stuff. Second calc, maximum. Don't select minimum, select maximum. Got to go left of it again, so it's all this tedious. Ooh. I'm pretty clearly left of it, I'd say. Enter. Now I've got to go right of it. I hope this is exciting. And then have I found it yet? Yeah, good, because it's saying guess. And now it's flashing where it should be. Good. My maximum's at 2, y equals 2, and x is pretty muchly 2, isn't it? 2 and 2, yeah. I would assume, because it's sometimes slightly inaccurate, so assume it was meant to be 2. 2 and 2. So let's plot it at 2 and at 2. And sometimes to impress the examiners, sometimes I'll even put those points on. I'm even marking those coordinates to prove to them I did find the exact point. And then do a little thingamajiggy. Photograph that little bit. You do it however it works for you. Make it show asymptotic behavior. Don't let it.
Don't do that.
Don't do what I just did. Let's do it again. I can't seem to control this. And yeah, don't make it curve around. Like, see, my one on the left here is a bit dodgy. It looks like it's touching the asymptote. So try to make it a bit less like that. I find it hard to do in this board though. And this one's kind of just going like that, and I can't be bothered doing it right now. So that kind of thing. So you could find, just double check the heights. Like you might want to check this little point. Here. What's dodgy about me doing that? Why might they take a mark off me? Oh yeah, that's a good point. I crossed the asymptote. That's a bit dodgy. But something else as well? Yeah, the question states it has to be from -1 to 5. So make sure your graph doesn't go beyond, because you'll notice I'll stop points on yours if you do that. So make sure, see here, I'm still even beyond 5 at that point. I want it to stop where the 5 is. So you can just draw it and then you can just erase off or cross out, scribble out anything that. So if you do go over, just feel free to just scribble it out. Then you've technically said that's not part of the answer. And as I said, sometimes I like to impress my examiners and put in coordinates so you don't need to. Like I'll do stuff like that just to prove that I've gotten the coordinate.
They wouldn't give me active off.
Nah. But maybe if your part was a little bit off, but you put that there, they might overlook the fact that your point was a bit off, 2 and 2. But if your point's at 2 and 2, I don't think you really need to bother. And once you've found all those numbers, sometimes it is worth writing them down, because maybe later on they're going to ask for those numbers and you've forgotten what they were. So it can be worth writing them down. Or look to see how they're going to ask that. Write down the coordinates of the local maximum. So you found it, 2 and 2. And to do that we did second calc max, just to remind ourselves. You don't get any marks for writing out the calculator instructions. We're just doing it for ourselves. Why is it called, does anyone know why it's called a local maximum as opposed to a global maximum? Yeah, sorry.
We're finding local minimum. Which one?
Oh, there was a maximum, local maximum. Yeah, it's a max. So second calc max, that says, why is it called a local maximum point and not a global maximum point? Do you know the difference between those two? Laura? Yeah.
That's the maximum of one of the large things.
Yeah.
That's what I felt further on the other keywords.
Exactly, yeah. So it's a maximum of a particular area, but it's not the highest point ever on the whole function. So if it was a global maximum, it would be the highest point that could ever be possible. But we don't have that on here because this one goes up forever. So a local one is when it's just for part of the graph. I don't know if that makes sense. Okay, so here we go. The line y equals x intersects the curve 3 times. Find the coordinates, x coordinates of those 3 lovely points. So you can do it by graphing, but in case you did something wrong with your graphing, try to do this so that you get a mark. That's x equals 3 plus 1 over x squared minus 4x plus 3. So showing that kind of could get you a method mark. So you're just setting the 2 functions equal to each other. Just in case you did graph it and you got something wrong when you found the intersections, just do something like that. Do a bit of algebra if you want, like subtract 3, multiply it with this business if you've got time. But I would at this point now do it on the graphing calculator. But this gets me a method mark. It's worth 3 marks, so probably 3 marks just for your 3 answers, but just in case I got an answer
So
wrong.
what would you have to do?
Just set the 2 functions equal to each other, just to make sure, like, you know, if you got a mistake here, you might get it. You'll get a method mark for that, and then just go ahead and sketch the thing.
No, what two functions?
Oh, see y equals x, and this one. So set the 2 functions equal to each other.
And then solve the x.
Yeah, and then graph them both. So we've got y equals x is our second function. Here they are, and then to solve for the 3 points, what do we press? Second.
Count.
Intersect, yep. So just select number 5 or scroll down to number 5. Oh, went too far. I'll just press 5. First curve, enter. Let's see where it goes first. Second curve, enter. Guess. Have I got it yet? I've got to press it, good. So notice it'll find the one it's closest to. So we've just found x equals 2. We've found 1 baby. How do I then find the other ones? What do I need to do before I go second calc intersect again?
Use the pressure.
Yeah, move so you're closer. Oh, sorry. Is that what you're going to say? Yeah, move so you're closer to the other one, and then it'll, by preference, find that one. And then go second calc intersect. That's my way of doing it. Second calc intersect. Enter, 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 and it just found the same one again. Great. Okay. I need to go just more clearly. Oh, that's weird. Ah.
You have to do sack with count into sack and then move it.
And then move it? Oh, okay, that might be the way. I think I've forgotten how to do things. Okay, second calc intersect. I'll try this one more time. Enter, enter, enter. I think it's because I'm not there. Whatever, it got this one. Good. What's that? 1.38? Is that 1.38?
Yeah.
Thanks. 3 sig figs? Yeah, but that's good. I'm glad you said that because got to remind us of our 3 sig figs. Where's the other one? It's over here somewhere. So, is it 3.62?
Yeah.
I believe you. 3.62. For the sake of the video. 3.62. TI 80.